Imagine looking up at the stars and knowing that one of them might be home to an advanced alien civilization. Not just a civilization that lives on planets like ours, but one so advanced that it has built an enormous megastructure around its star to capture nearly all of its energy. This concept, known as a Dyson Sphere, has fascinated scientists and science fiction fans alike for decades. But could we actually detect such a civilization by its energy usage? The concept of a Dyson Sphere was first proposed by physicist Freeman Dyson in 1960. Dyson speculated that as a civilization advances, its energy demands would grow exponentially. Eventually, they might need so much power that the only logical source would be the entire output of their home star. To accomplish this, the civilization could construct an immense structure around the star, allowing them to harness nearly all of the energy it produces. This kind of energy capture would be characteristic of a Type II civilization on the Kardashev scale. This scale, proposed by Soviet astronomer Nikolai Kardashev, categorizes civilizations based on their energy usage. A Type I civilization uses all the energy available on its home planet. A Type II uses all the energy from its home star, and a Type III civilization could harness the energy of an entire galaxy. Building a Dyson Sphere would be a natural step for a Type II civilization, a colossal leap beyond anything we can currently imagine. The term Dyson Sphere can be misleading, as it evokes an image of a rigid shell completely enclosing a star. In reality, such a structure would be mechanically unstable and incredibly difficult to construct. Instead, scientists and theorists envision other, more plausible versions of a Dyson Sphere, such as Dyson Swarm, a massive number of individual solar collectors or satellites orbiting the star in a dense formation, all working together to capture its energy. This version is the most realistic in terms of engineering feasibility. Dyson Bubble, a series of large, lightweight solar sails that are held in place by the star's radiation pressure. These sails would be dispersed in a way that allows them to collect energy while remaining in stable positions around the star. Dyson Shell, the classic idea of a solid shell enclosing the star, although this version presents significant engineering challenges, such as gravitational instability and material requirements. Detecting a Dyson Sphere, or any similar megastructure, is a tantalizing idea because it represents one of the most straightforward ways to identify an advanced alien civilization. But how would we go about detecting such a structure? The key lies in energy and light. A Dyson Sphere would alter the way a star emits radiation. Here are some ways we could detect it. Infrared signature. A Dyson Sphere or Dyson Swarm would capture most of a star's visible light to convert it into usable energy. However, not all of this energy would be efficiently used. Some of it would inevitably be re-radiated as waste heat. This waste heat would most likely be emitted in the infrared spectrum. In other words, a star surrounded by a Dyson Sphere would appear unusually dim in visible light, but very bright in infrared. Astronomers have long been searching for stars with this kind of infrared excess. The Wide Field Infrared Survey Explorer, WISE, and other infrared observatories have scanned the skies looking for objects that exhibit unusual infrared signatures that might suggest the presence of a Dyson Sphere. So far, while a few candidates have been identified, none have been confirmed as alien megastructures. Unusual light curves. A Dyson swarm would create complex and irregular patterns of dimming as the individual components pass in front of the star. This could result in strange light curves that do not match the usual patterns caused by planets. The star KIC 84628552, also known as Tabby's star, is an example of a star that has shown irregular dimming leading to speculation that it might be surrounded by a partial Dyson structure. While the most likely explanation for Tabby's star is a cloud of dust, the idea that it could be a Dyson swarm captured the public imagination and reminded us of the possibility of alien megastructures. SETI and targeted searches. The search for extraterrestrial intelligence, SETI, has also taken an interest in detecting Dyson spheres. By analyzing data from infrared telescopes, SETI researchers hope to identify anomalies that could indicate advanced civilizations. They have even developed specific algorithms to sift through the vast amounts of data collected, looking for anything that defies natural explanations. Although these searches have yet to yield concrete evidence of alien megastructures, they remain an important part of our efforts to find extraterrestrial life. While the idea of detecting a Dyson sphere is appealing, there are significant challenges involved. Natural explanations. Many phenomena could mimic the signals we expect from a Dyson sphere. Dust clouds, planetary debris, and even unusual stellar activity could all produce infrared excess or irregular light curves. Distinguishing between a natural cause and an artificial one is extremely difficult. Technological limitations. Our current technology may not be sensitive enough to detect a Dyson swarm around a distant star, especially if the components are small or dispersed. Additionally, if an alien civilization were to build a Dyson sphere, it might be optimized in a way that minimizes waste heat, making it even harder to detect. Different technologies. It's also possible that an advanced civilization might use a form of energy capture or technology that we cannot currently conceive of. The Dyson sphere is based on our understanding of physics and engineering, but a more advanced civilization might have entirely different solutions to their energy needs. The search for Dyson spheres is part of a broader effort to understand how energy usage might signal the presence of alien civilizations. As a civilization grows, its energy requirements increase, and how it meets those needs can tell us a lot about its level of technological advancement. The Kardashev scale provides a useful framework for this, with Dyson spheres representing a significant milestone in the transition from a Type 1 to a Type 2 civilization. In a way, searching for Dyson spheres is about looking for evidence of a civilization that has learned to fully harness the resources of its home system. It suggests a society that has moved beyond the challenges of planetary life, solved its energy problems, and expanded its reach. This concept ties into the broader questions we often ask. What is the fate of advanced civilizations? How do they overcome existential challenges? And could a Dyson sphere be a solution to what we call the Great Filter, the unknown barriers that may prevent civilizations from surviving long enough to become interstellar? Detecting a Dyson sphere would be one of the most profound discoveries in human history, providing direct evidence that we are not alone in the universe. While we have yet to find definitive proof of such megastructures, the search itself is valuable. It pushes the boundaries of our technology, challenges us to think beyond our planet, and reminds us of the vast possibilities that exist in the cosmos. As we continue to explore the stars, we keep our eyes open for any sign of advanced civilizations, whether they come in the form of unusual infrared signatures, strange light curves, or other unexpected phenomena. The search for Dyson spheres is a reminder that the universe is full of mysteries, and that some of those mysteries may point to the presence of other intelligent beings, striving to harness the power of their star, just as we might one day strive to harness ours. To explore more cosmic mysteries and dive deeper into the universe's secrets, subscribe to our channel and share your thoughts in the comments below.